Okay, let's be back after the break. And there's been many questions about the difference between RUP and Agile, right? So this is the Agile Manifesto, right? I think most of you would have gone through this Agile Manifesto. Uh, am I audible? Let me just check before I move ahead. Okay, I'm audible. And I hope all of you have got your pen and paper also, because just two more slides and then we'll start with some use case diagrams. Okay, fine. So this Agile Manifesto, this was written in the year 2000, right? And as you remember, in the previous one of the previous slides, I showed you that the Object Management Group, or OMG, came up in 1997, right? So these were the two ideologies which actually came up almost at the same time. So object orientation came up in 97, and then it was in 2000 that the Agile people wrote the manifesto and they came up with the Agile ideology, right? Agile ideology specifically says that do less amount of documentation, right? Create only as many documents as required. Do not add documents. Now by documents I mean work products. So do not create work products which are which do not add value to your process, right? And another important thing that the Agile ideology focuses on is involvement of the customer during the development of the project itself, right? So it is the customer should not be briefed about the project at the end of 6 months, right? He should be a continuous participant in the software development process, right? So this is what is stated in the Agile Manifesto as well. Focus on individuals and interactions, then process and tools, right? So before reading the manifesto, just read the last line. What it says is that while there is value in the items on the right side, we value the items on the left more, right? So why there is value in the items on the right side, we value the items on the left more, right? So put more emphasis on individual and interactions rather than processes and tools, right? So this was one major drawback of the waterfall model. There was it focused so rigorously on the processes and tools and heavily on documentation that you actually lose your aim, your motive of developing a working software, right? So put emphasis on working software rather than comprehensive documentation. Have continuous customer collaboration rather than contract negotiation, right? So it is that after 6 months we'll come and give you a demo, and then uh, you get to know that this was actually not what the customer had expected, right? So why not bring in the customer initially into your project, right? Respond to change over following a plan, right? So do not have a plan in which you cannot accommodate change, right? So this was the main ideology with which the agile people moved ahead. And again, if you just read on to the book, you will find that in one of the chapter in the RS Pressman book or other books also, you will find n number of process models which are based on the agile ideology, right? So whenever you come up with an ideology, you give associated process models, right? So whether how rigorous you follow a plan, how rigorously you follow a plan, but still you need a plan, right? This was what agile ideology followed. Now, how agile and unified process came to join in, right? The agile people found that the unified process adopted something very important, which is called UML, right? The unified process advocates use of unified modeling language to design the work products. Now, this unified modeling language, which they found, was an excellent diagrammatical language, right? So unified modeling language is based on notations which are like diagrams, right? So these agile people, they found that this UML was kind of really exciting, and they wanted to join or wanted to make use of UML in an agile manner, right? And I I've just skipped a few slides. So one of the drawback of the unified process was that it is flexible, right? It can be considered as a drawback or it can be considered as an advantage, right? So if the unified process is not properly documented, that makes it more flexible, and that is what the advantage the agile people picked up, right? So they picked up the whole ideology of the unified modeling language from the unified process, and they used UML as a sketch, right? So because at that time it was mostly the object oriented ideology which was picking up, and then the agile people, they came up with the ideology is that do not put too much emphasis on creating the work products, bring in the customer together, and together the two ideologies joined, and agile ideology picked up one very important thing from the unified process is that the use of UML. So they picked up the specific diagrams, the UML diagrams from each phases, right? And sort of formed a combination of any agile process and put in the use of that particular diagram into their own phases, right? But another important thing is that they used UML only as a sketch, right? So it was a freehand kind of a ideology in which they used UML. And this is how agile and unified process joined in, and this is how the UML became so popular, right? So it is not the unified process is what many people know, but it is the UML is what many people know, because it became even more important, even more famous when the agile ideology adopted UML and associated diagrams into their own software process models and used it to create quick work artifacts, right? Okay, moving ahead. So this is one of the research paper that I would suggest that all of you should read through. This is the initial paper that was published in '96, which actually talked about the unified process, and the paper is the best read for this particular process because it is written by the original authors of the unified process. I would upload this paper on the eLearn portal, right? Uh, if that is allowed, I don't know, okay? But at least those who have access to the IEEE repository, please download this paper and share across with you, with each one, with the others, and please go through this paper. It's a good read, right? So I mean, you get to read a paper by the original authors of a process. I mean, what better can be that? Okay, so please read this paper. Okay, now we move ahead to UML, right? So I think you must be wondering, where is UML so far? So unified process states that there are certain artifacts that have to be created in each phase, right? And those artifacts which we will focus on have to be created using the diagrammatic notation, which is called the Unified Modeling Language, or UML. right? I'll just take 2 or 3 more slides to bore you people, and then we'll move on to the case study. So the Unified Modeling Language, or the UML, describes notation for number of different models that may be produced during object-oriented analysis and design, right? So it is strictly only for object-oriented analysis and design, because it's a part of the, it was initially integrated through the unified process. Right? The unified modeling language is a visual language, and some of its characteristics are that it is visualizing, specifying, constructing, and documenting, right? And currently it is a standard notation for documenting or creating object-oriented documents, right? So there are 2 websites I think you can refer to, www.uml.org or www.omg.org, right? So these are the 2 official websites for UML as well as Object Management Group, right? So those who would like to have know more about the Object Management Group or the Unified Modeling Language can always visit these 2 websites. These are the official websites of the OMG group, or of the Object Management Group, or the Unified Modeling Language Group, right? Okay. UML is visualizing. What do you mean by visualizing? In case you see something represented diagrammatically, right, it is more appealing, right? It goes into your brain, right? So that is the whole idea behind UML being a diagrammatical language, right? So say for example, if I say an apple, right? So the moment I say an apple, what you think is about a pictorial representation of an apple in your mind, right? So this particular kind of a language, because it deals with more diagrams, gives you a better understanding of how the system is represented, right? It is specifying, right? So it becomes a specification standard, right? So the UML is now a specification standard. So whatever you draw using the correct UML notation, using the standard UML notation, and you pass on that diagram to your team members sitting on the other side of the globe, you can definitely make sure that this person will also understand this particular document, right? The reason being, it is being standardized as a notation for specifying the requirements, right? So it is used as a specification concept. It is used as a specification language, right? It is also used as a constructing language, so it helps in both forward and reverse engineering. So in case you have to, I mean, this is the reason we create diagrams. So if I have to write certain code, right? You create a diagram and then write the code. Or if I have a code, if I have to understand it, I draw a diagrammatical representation of the code and then write it, right? Okay, and then it is a standard for creating the documentations, right? Okay, I think that's it for the UML. The UML is used. Okay, this one slide is what I would like to emphasize on, right? There are 3 ways in which UML can be used, right? The first one is the UML can be used as a blueprint, right? So that is, you create detailed diagrams using UML, right? So you emphasize on creating detailed UML diagrams using sophisticated tools, right? When you refer to using the UML, right? So you're using UML in a detailed manner. The other way is using the UML as a sketch, right? Have a rough diagram, right? You have a pen and a paper, you have a whiteboard, you draw the UML diagram, use the notations, but you are freehand, you are not so rigorous, right? And this is what Agile does, right? So your Agile is what uses UML as a sketch, right? And you can also use UML as a programming language, right? So this idea is somewhat in a research phase, that you draw a particular diagram using a sophisticated tool, and the tool is able to generate an associated code based on the given UML diagram, right? These are the three ways in which the UML is being used currently in the industry, right? So I'll just give you 2 minutes. Please pick up your pen and paper. So we'll go to start with the use case diagram. There are a few slides I'll skip because it's getting boring, right? So your use case diagram is the first diagram which is being drawn in the inception phase, right? What you do in the use case diagram is you need to identify all the use cases, right? What do you mean by use cases? Use cases are how a system can be used by a user, right? So in the inception phase, you analyze 10% of your use cases. And in the inception phase, the use cases is one of the most important diagrams which is drawn, right? Okay. Now you will find in fact, three things, right? So one is a use case model, right? I'm typing something on the screen. Is it visible? It's not. Okay. Anyways, I think there's a lag, right? So there is something called as use case model. Use case model comprises of two things. One is use case diagram, and the other is use case text scenarios, right? Your use case model comprises of use case diagram and use case text scenarios, right? In use case diagram, you list down all the use cases of the system, right? That means what are the ways in which the system can be used by a user, right? Now, for each use case, you need to elaborate. Elaborate in terms of text, written text, right? Which is like a story as to how this particular use case is unfolds, right? So your use case model comprises of set of written use cases, right? Which are text documents which explain the functional requirements and are written in the form of stories, right? A use case is being used by an actor. An actor is somebody who is interacting with the system, right? Okay, there can be three kinds of actors. There is a primary actor, a secondary actor, and an off-stage actor, right? The primary actor is the one which has his goals fulfilled by using the system, right? So he's the main user of the system, right? The secondary actor provides additional resources to the system, right? So it would be often a computer system, an external person, or an external organization, right? The reason we do identify a secondary actor is that because this secondary actor also acts as a stakeholder, right? He has interest in the system, he is an important stakeholder and provides certain services to the system, right? So this particular secondary actor is also represented. right? Apart from this, there is an offstage actor, right? This is an actor who has an interest in the use case in the system, right? Because again, he's an stakeholder. But this particular offstage actor might not directly interact with most of the use cases, right? Okay, we'll see, move ahead as we see more notations. So here we come with the notation. So your use case diagram provides a picture of the system. You have to draw a system boundary. Everything, all the use cases inside the system boundary, which is drawn using a rectangle. All the primary actors on the left, the supporting actors and offstage actors on the right, and every actor is represented as with the help of a stickman figure, right? Okay, I'll take you to the next slide first, right? So this is how a partial use case diagram looks like. I'm just emphasis is on the notation. So this is your stickman figure, which represents an actor. Left hand side, you have the primary actors, and right hand side, you have the supporting actors, right? You use an ellipse an ellipse to represent a use case, right? So in this case, process sale is a use case. There is an outside boundary which represents the system of which represents the entire system, right? Additionally, here if you would see this particular actor, right? This cashier is also an actor, but he's the primary actor, whereas this payment authorization service is also an actor, but a secondary actor, right? And that is the reason the secondary actor is on the right side, right? But there's another reason, there's another difference if you see in the notation, that this secondary actor is not represented using a stickman figure. The reason for this is that this secondary actor is a non-human entity, right? So in case there are actors which are non-human entities, you can represent them using a box with this kind of a symbol written on top of them, the actor symbol, right? So I'll just take you one slide back, and it says use actor symbol, which is a UML keyword or a stereotype enclosed in two special symbols called glimmets, right? This is not two arrows. This is not two closing arrows, right? So you can find these are two special symbols which are called glimmets to represent non-human actors, right? So you put the word actor and then put it into a square box or rectangle box to indicate that this is a non-human actor, right? Then your use case is drawn using an ellipse with its name, not an ellipse, sorry, ellipse with its name inside the use case, and the use case is connected using solid lines to actors that communicate with it, right? So a use case is represented with solid lines, to the use case, right? Now, one very important thing in UML notations, there is a big difference in solid lines and dotted lines, right? So wherever it says that there has to be a solid line, it is a notation, right? You cannot change it. If you instead of solid line you draw a dotted line, it's incorrect, right? Similarly, if you see in this association line, there is no arrow, right? So this has to be kept in mind. So even in this model and the models ahead, it is very important that you keep into mind whether it's a solid line, whether it's a dotted line, whether there are arrows, and then arrow is pointing where, and then there are different types of arrows as well, right? There's a filled arrow, there is an unfilled arrow, there is a simple arrow. So all these notations is what is important when you will draw diagrams using unified modeling language, right? And this has to be kept in mind. Okay, this is the alternate notations that you can have for the actors, right? So you can even draw a stickman figure for a non-human entity, although this is discouraged, right? So it's always good to have this kind of a notation for a non-human entity, right? So this is a sample use case diagram. It's a partial use case diagram for next gen point of sale system, right? What is this? What is next gen point of sale system, right? So I'll explain you this first. If you would have gone through your textbook, which is applying UML and patterns, in first one chapter, the textbook talks about this particular case study, right? It is a next generation point of sale system, right? So there is a complete one small chapter which describes this case study. You should go through this case study, and then the book takes this case study throughout all the chapters, and they discuss all the models and all the applications of the design patterns as well based on this case study, right? So please go through this case study, and I'm not going to go through this case study uh, in this particular online sessions, because this case study is what is being even discussed in your digital content. This case study is the one which is there in the book. So we will take different case studies for the purpose of these online sessions, right? However, this is what the final aim is, what we're going to draw, right? So let's start with our snakes and ladders example, right? We will start with the simplest uh, version of our snakes and ladders, right? And we'll draw the use case diagram for this particular system. So consider your simple snakes and ladders game wherein two players take turns to roll the dice and move their coins on board. Right? The player whose coin crosses the 100th mark first is the winner. Right? So the first thing you need to do is identify the use cases for this particular case study. Right? Can you please identify the use cases, right? So what we are looking at now is that we want to know the use cases, that is the scenarios in which this system can be used by the actors. As well as we also want to know what are the various actors in this particular case study. Right, so I'm just waiting for you people to type in. Okay, I think the chat is moving too much. Let me just see. There's so many messages. Okay. You are telling me snakes, ladders, dice, coin. These are the domain objects, right? Domain concepts that we identified, right? What are the use cases, right? So the use cases are roll the dice. Okay. So one person says use the case is roll the dice, and then we have one more input which says move the coin, right? Okay, and there are actors which says, okay, so some people say actors are players, and then some even say it is player 1 and player 2 because we say there are 2 players, right? And some even say coin and dice are the actors, right? Okay, uh, okay, right? Given this case study, there are only 2 use cases. One is roll the dice, the other is move the coin, right? Your players, what is your players can do with the system? What is the thing that the 2 players can use the system for, right? So they can use the system to roll the dice, or and not or and they can use the system to move the coin, right? Which are the actors, right? There is only one actor in this case, which is a player, right? We will not say that player 1 and player 2 are 2 actors. There is only one actor. Player 1 and player 2 will be 2 instances of my actor, right, which would exist at the time of implementation, right? And this can take any number. So there might be 2 players, 3 players, 4 players. But currently, there is only one actor, which is a player, right? If you again read the description, who is the person who is using this system? There is only one person who is using this system, which is a player. And how is he using the system? He can roll the dice and he can move the coin, right? There will be no player 1 or player 2, right? It is the you can say the actor player represents all the players that would exist in the system, right? So we will not separate them out into player 1 and player 2, right? Coming to next, why not board, coin, and dice, right? So people are asking me, why not coin, dice, and board as actors? They are not actors. They are not using the system, right? In use case diagram, you just have to capture the users, that is actors, and how they can use the system, right? I know coin, dice, and board are part of the system, but they will come in the other diagrams. The use case diagram will only have an actor, which is a player. He can roll the dice and move the coin, right? I'll show you the diagram, right? This is how my diagram would look like. So there is an actor, which is a player, right? He can roll the dice and can move the coin, right? And both the use cases are inside a box, which is my system boundary, and the actor is placed outside the box, right? Please don't be bothered as to who will win, how will the board be placed, how will you roll the dice, right? This is not what you are expected to capture in a use case diagram, right? Please be clear as to the requirements or the concepts that have to be captured in a particular diagram, right? Your use case diagram focuses only on actors and the way the actors can use the system, Rest is all next, right? Who's going to win, who's going to lose, that is not my point. Given a system, right, where given a system to a customer, how will that customer use the system is what we are looking for, right? We need to only find out how the system can be used, right? Declaring a winner is not how the player can use the system, right? So in the player in use case diagram, we only capture the users of the system, right? I'll move to the next level, and I think you would be able to understand much better, right? So I take the modified version of the snakes and ladders, right? So this was our modified version. Just go through it. Okay, so this is my modified version of the use case of the snakes and ladders, which says that it is a configurable system, right? So my player, one of the player can configure the snakes and ladders, right? And then the game is played in the usual manner, right? So now in this case, right, because we say that the game is played in the usual manner, my roll dice and move coin are there, right? Other normal use cases will be there, right? And I have an actor player, right? What additional the player can now do with the system is that the player can configure the snakes and the ladders on the board, right? So I would take this to the next level, wherein says that my modified solution looks something like this, right? So I have a player, right? And he can roll a dice, he can move a coin, he can configure the snakes, and can configure the ladders, right? Okay, I think clear so far, right? There's something more coming in the chat. I'll take up next, but I hope it's clear till here. You say we need a special player and a player. Why can't we make two players? No, we only represent one instance of a particular actor in the use case diagram. Okay, let's move to the next version. Okay, before moving to the next version, so here I need to introduce one notation which is used in the use case diagrams, right? This is called an include relationship, right? Now what's happened in an include relationship, a larger use case can be factored into simpler use cases using include relationship, right? This kind of a decomposition is used to avoid repetition, okay? Or describe in details some other sub use cases, right? So if we find that there are certain use cases which consist of sub use cases which are of equal importance, and we would want that they are represented in the use case diagram, then we use the include relationship, right? How it is drawn? We use a dashed arrow with a limit with the stereotype written as include, right? Okay, move ahead. This is how it looks like, right? So this is for the next generation point of sale system. If you see here, this is my process sale use case scenario, and it includes 3 sub use cases, right? So the moment you say there's a process use case, it can handle check payment either through cash payment or credit payment, right? Now we'll come back to the snakes and ladders and we see that it becomes more clear. Now if you see, I have modified the solution, that the use case diagram that we had drawn earlier, to add the includes aspect, the includes notation, right? The player can configure the ports is what we say, right? And within this, he can configure ladders or configure snakes, right? I hope this is clear now, right? Now what this includes helps us to do is that if there is a use case which consists of sub-use cases, then we try and decompose that use case into sub-use cases which are of importance, right? So a player can configure a board, and this main use case consists of two sub-use cases, which is configure ladder as well as configure snakes, right? The reason to add and includes or sub-use cases is not only reusability but also decomposition, right? So these are the two important reasons why we use includes, right? It is reusability as well as decomposition, right? Why can't we use the previous scenario? That previous scenario is also right? So one of you are asking is that why can't we continue with the previous kind of a stuff, right? That we have configure ladders and configure snakes, right? That is also correct, okay? But this is a more better representation than that one, because it is capturing the use cases at the higher level and then defining them and then refining them into sub use cases, right? So when you draw use case diagram, you must refine it to the level possible, okay? You cannot simply say that I will have only roll dice, move coin, configure ladder, configure snakes, right? This is going to definitely get you less marks, right? So if your case study describes that there is a main use case and there are sub use cases, then you must capture those sub use cases. Yes, this includes is represented using a dotted line, right? So there's a dotted line with an arrow pointing towards the sub use case, right? Let's move ahead, and I have another solution here. Okay, let's see what's happening in this. So in case of configure ladders, there is another sub use case which is possible, that I would set the starting point and set the ending point of each ladder, and then in configuring say snakes, I set the mouth or I set the tail, right? So this is decomposing it further using your includes relationship. Your configure board can be decomposed into configure ladders and configure snakes. Then your configure ladders can be decomposed into set starting point and set ending point, and so on. Okay. Uh, one more thing that I would like to tell you at this point of time, these diagrams are created using a tool which is called Star UML, right? And I have posted an announcement on the eLearn portal that you can access the BITS lab platform, which is called Platify, using the eLearn portal. and also listed there which are the courses for which the labs are currently available. One of the advantage of this portal is that it has all the required tools pre-installed inside it, right? So you have a few lab exercise, or you can call them case studies for OOAD, which are uploaded there, and also the star UML tool which is available there. So instead of downloading the tool and installing it on your machine, you can access the Platify platform and access the star UML tool from there. Okay, we go back with our discussion of the use case diagram. So your configure board is divided into sub use cases. Let's see what I have next. So that's a solution 3, right? What you see in your solution 3 is I have subdivided roll dice and move coin also. No, sorry. I've put a main use case in the starting which I say player can actually play a game, right? And while he plays a game, there are two sub use cases in that play game. He can roll a dice or he can move a coin, right? There are a lot of questions that are coming in the chat where it's saying that how will we know the winner, how will we know the position, right? This is not what we are trying to capture in a use case diagram. Please, this is very important to remember. A use case diagram, when you're drawing a use case diagram, do not think about the class diagram or the implementation. Only look for the actors of the system as well as the use cases, right? And try to capture the main use cases and subdivide them into sub use cases. Okay, now there's another question, can we have a reset use case? Yes, you can have a reset use case. You can have a logout use case, then you can have a refresh use case, right? See, these use cases are not the main use cases of the system, right? If you if you draw a logout use case but you miss out a play game use case, definitely you're not going to get the marks, right? So the idea in a use case diagram is to capture the important use cases. Definitely every system has a logout button, so if you just want to add a logout use case to your diagram, good enough, you're not wrong, right? But then let's draw something that gives more sense and more knowledge to that diagram, because this diagram is what we will use in subsequent implementations, right? So this use case diagram is what moves ahead into the design phase, and then you use this diagram as you move ahead, right? So why not, it's an important diagram which is being drawn, so why not capture the important aspects into this particular diagram, right? Okay, so this was one solution. Let's move ahead. Now there's another relationship that you can capture in a use case diagram, which is a generalized relationship, right? So a use case can be specialized or generalized into one or more use cases. So when you go for a specialization, it can be specialized into one or more child use case, right? And any child use case may be used in a situation in which the parent use case is expected, right? This kind of a relationship is similar to the inheritance relationship, right? I'll give you an example. So this is the example of a generalization relationship in use case diagram, right? So you have a use case make payment, right? It's obvious that the user will make payment either through use case 1, 2 or 3, right? That means one of these 3 child use case will be used instead of this make payment, right? So this is my super class. Effectively, these sub use cases will be the ones which will be realized, right? So here we can say that any of the child use case can in practice replace the main use case. So my customer can use the system to make payments, but he would either make payments through use case 1 or 2 or 3, right? Let's see if we have this kind of a relationship in our snakes and ladders. Okay, so in the current scenario we don't have. Let's go to the let me just try and share the snakes and ladders case study that I have uploaded on the eLearn portal. It'll just take a few minutes. Okay, so this is the case study. I hope it's visible. How do I know if it's visible? Can I see the chat? Okay. Okay, it's visible, right? So this is the case study, the snakes and ladders case study that I have uploaded on the eLearn portal. It's a pretty elaborate one, and I hope you would have gone through this. Right, so I'll just quickly go through this. It's a snakes and ladders project, right? So there is a game owner who's required to choose the number of snakes and ladders that are to be placed on the board, right? So it says that there is a game owner who can choose the number of snakes and ladders. So this is the person who is actually responsible for configuring the board, the game owner, right? And he can choose the number of snakes and ladders, as well as he can choose the starting and ending point of the snakes and ladders, right? This is how the game board would look like. Then, okay. The game owner can invite players to play the game. At any instance of time, not more than 4 players, including the game owner, and not less than 2 players, including the game owner, can play the game, right? Individual player coins are drawn as colored circles and placed on the board. There is no differentiation between the coin of the game owner and that of the other players. Finally, each player, as well as the game owner, gets turns to roll the dice, right? Which is a random number between 1 to 6 and play the game, right? The reason I'm trying to read this elaborate case study is that you will get case studies like this, right? But if you read this case study, it's giving you so many implementation details that it becomes difficult to extract the use cases and the actors from such a detailed case study which has so much focus on the implementation aspect, right? Now it says that this game can be played in multiple modes. There can be an even odd mode, multiple coin mode, or an hybrid mode, right? What is the even odd mode? In the even odd mode, the player needs to choose whether he wants to play an even or odd mode. In even mode, say if the player chooses an even mode, then he will move his coin only when he would get an even number on his dice, right? And in the odd mode, the player will move only if he gets an odd number on the dice, right? Now, in the multiple coins mode, for a particular player, two to four coins can be placed on the board. However, the number of coins for all the players should be same, right? So the players can place any number of coins on the board. For each player, there can be 2 to 4 coins, but every player should have same number of coins, right? This is your multiple coins mode. And who will win? The player for whom all the coins have crossed 100th location will win, right? Then finally, there is a hybrid mode. In the hybrid mode, it can be a combination of the even odd mode and the multiple coins mode, right? Now, this is your entire case study, and if you read this, it gives you too much details about the implementation, and it becomes difficult to find out the use case diagram for this, right? Now we'll go back. I'll stop sharing this and we'll go back to our session. Okay, I think we are back. And now let us have a look at the use case diagram that I've drawn for this particular case study. Okay, now this is the use case diagram, right? If you see the lower part, I have not touched it all. So there is configure board, there are configure ladders and set the points, right? Let's take a quick look at the upper part. Before that, now as per the description given, there are two actors now, right? There is a player and there is a game owner, right? It is the game owner who can configure the boat. The player cannot configure the boat, right? The game owner invites the player to play the game, right? And the game owner can also play the game, right? So this is how you differentiate between a game owner and a player. A player can only play a game, whereas a game owner can also configure the board, invite players, as well as play the game, right? Keep this, study the use case, the case study again. Keep this diagram in front of you and then try and go through it, right? Okay. Now next, coming to the generalized relationship that I have put in here. Your player can play the game, right? Now what is this thick white arrows? This is a generalized relationship. When I say the player can play the game, he can play the game either in a normal mode, hybrid mode, even odd mode, or multiple coins mode, right? The moment we say that a player can play a game, right, it will be in either one of the 4 modes. There's nothing other than that, right? That is why there is a generalized relationship in this case. Each one of these sub-use case can replace the play game use case, and in fact, each one of these sub-use case will replace the play game, right? At least one of them will definitely replace the play game, right? The user will play the game in one of these modes. That is why there is an inheritance relationship, or we say a generalization relationship, and not an includes relationship, right? Includes relationship comes when they are subparts of a use case, whereas a generalization relationship comes when they are actually child use cases, where they will replace that particular use case in any case, right? Okay, and then you can go through all the includes that are there. So in every mode which is there, there are sub use cases wherein you can choose even mode or choose odd mode, or you need in the multiple coin modes, you need to choose the number of coins under, that you need to play, right? Okay. One last concept, so there can be generalization of actors as well, right? So in this case, uh, let me just see what is it, what do you mean by generalization of actors? So actor generalization refers to the relationship which might exist between two actors and which shows that one actor inherits the role and properties of another actor, right? It also implies that the descendant actor can use all the use cases that have been defined for its ancestor, right? So you can have a generalization relationship in actors as well, and this leads us to the modification of our use case diagram further, wherein if you see now I've added an arrow, a generalization relationship arrow between the game owner and the player, because my game owner is also a player, right? And I have removed the line connecting game owner and play game, right? That is to represent that because game owner is a specialization of player, he will have access to all the use cases the player has, right? Whereas a game owner can only access the invite player and configure board use cases, while player cannot do that, but the game owner can access the play game as well. Right? I think that's it for today. This is what a use case diagram aims to capture, and this is what you are expected to draw given a case study. Given a case study, if you're asked to draw a use case diagram, please identify the way the system can be used by the actors and what are the various actors. Right? I'll quickly take up one or two questions. Offstage actors are represented as stickman figure if they are humans, otherwise represented as non-humans. Arrows can be outside the system box. Only the generalization relationship between actors will be outside the system box. I think it's fine for today. We'll close the session now. You can route in more questions in case you have to the discussion forums. I will upload these slides. Request you to go through the case studies, uh, to the snakes and ladders case study, and then again read this diagram. But this is what you are expected to draw in case of a question in the paper, right? Be as much elaborate as you can, but but also see the weightage. So for this question, for such an elaborate case study, the weightage would be something like 6 marks or maybe even 5, right? So if you need to capture that, you need to sorry, there are more questions coming in. So for 5 marks, this is what is expected. Quickly answering some of the questions. No class tomorrow. The agenda for the next session is that we will go through use case text scenarios, right? So use case text scenarios and domain model is what I plan to cover next time. So use case text scenarios is again a written story, so that's a pretty bit boring. So I will take that in the first half, and the second half we'll take the domain model and case studies related to the domain model. Right, I think we'll close right now. More questions, please route through the discussion forum, and then we can take up from there. Thank you so much.